Hey folks, today we're talking about the circle of fifths. The circle of fifths can seem really intimidating. The letters come in a weird order, and I find that people forget to tell you why it's important. Not just that it's important, but what it's used for. And the truth is that the circle of fifths is absolutely embedded in the structure of Western music. Let me show you. To begin our journey, we need to do a little bit of history. The fifth and all Western intervals were described by Pythagoras. I'm sure you know all about his famous triangle theorem, but he also did a lot of work with strings, hence the guitar. Pythagoras wasn't really obsessed with triangles, he was obsessed with ratios. In particular, he discovered what happens when you pluck a string that's been divided by very specific ratios. For instance, he discovered that if you divide a string in half, or a 1:2 ratio, that you get an octave. Dividing a guitar string in half is as simple as pressing on the 12th fret. But of course, anybody who's been playing guitar for a while knows that it goes beyond just pressing on the 12th fret. If you divide the string with a dampened finger, you can actually get the overtones to play, causing a harmonic. It's no coincidence that the harmonic that divides a string in half also creates an octave. It's also no coincidence that it takes 12 frets, as in 12 half steps, to get to the octave on the guitar. 1:2 is certainly the simplest ratio in existence, but it doesn't get you a new note. So Pythagoras moved on to the second simplest ratio, which is 3 halves, or 3:2. This ratio gives you a fifth. The 3 halves ratio happens exactly 7 frets up the neck of the string, or 7 half steps, or 1/5. The harmonic that's played over the 7th fret doesn't sound a fifth above the open string. Instead, it plays an octave and a fifth higher. In order, the open string, the octave divided at the half, and the fifth above that divided at 3 halves. Now for Pythagoras, the fifth was the purest interval. It was strong and it tuned beautifully. So in order to create his musical system, he continued stacking fifths on top of each other. So if he started on a note and played a fifth up, he would then play a fifth above that. And it turns out that you can do that 12 times before you get back to the same note you started with. This is a gross oversimplification. Pythagoras wasn't out to make a musical system, and the modern tuning system is vastly different than the one that Pythagoras came up with. However, the principle is the same. If you start on a note and you stack fifths 12 times above it, you will come back to the same note, according to our modern tuning system. But if you're not convinced that the circle of fifths is literally embedded in Western music, here's a picture that labels the divots in a steel drum. Notice how the letters in this diagram are exactly the same as the letters in this diagram. I just need to turn it a little. Now look at a bigger version of the steel drum diagram. Do you see how the inner circle is another circle of fifths? It just sounds an octave higher. And then there are 4 in the center, which sound yet another octave higher. Of course, there are 8 notes missing, but if you continue going in the same direction, you'll notice that they come in a specific order. So this isn't just an intellectual exercise, folks. The circle of fifths is physically embedded in our music. Now let's get to the fun stuff. People usually think of the circle of fifths as a way to organize keys. If you move down the right side, you get to add sharps for each step. If you move down the left side, you add a flat. But that's not the whole story. We can also use it to help us decide what chords we play and when we're writing a song. The general process of writing a song in the Western tradition is to start at a home chord, to move away, and then to return home. If you start with your 1 chord, that's the home chord, in the key of C, that will be C major, then we need to think of the steps on the circle of fifths as a step away from home. We'll start with some 3-chord progressions. I'm sure you've seen some of them online if you've been playing guitar. So let's go 2 steps. That gets us to D minor. Then we move a step back toward home, which gets us to G major, and then back to C. The progression sounds like this. A slightly longer progression takes us 3 steps to the right of C on the circle of fifths to A minor. Then, following the same process, we move back to D minor, back to G major, and back to C. The progression sounds like this. The final, slightly longer progression takes us 4 steps back to E minor. The progression is as follows: C, E minor, A minor, D minor, G major, C. You may be wondering why we don't go 5 steps back to the B chord. Well, there are several reasons, not the least of which is that it's a diminished chord and it's unstable and difficult to work with. But for now, just trust me that it's not a chord that you want to use. We'll get into how to use the diminished 7 chord later. You may also have noticed that we didn't use the F chord in any of these progressions. I'm going to save the F chord for another video, but in the meantime, I want you to see if you can figure out where it goes. Try to insert it between other chords in the progression, and also try to replace it. Once you think you've figured out where it goes, write out the notes of the chords that are next to it or that you've replaced it with, and see how they compare. See if you can figure out why the F chord works the way it does. Well, that's all for now. Next time I'll be covering cadences, how to use them and what they're for. I'm Michael Davidson, and this was CadentialM. Thanks for watching.